Shin, do you mind share your screen?
Yeah.
Thank you.
Okay. Right.
Great. Yes, it's now 9:05. Hello, folks, again. Today is October 21st, Wednesday, and this is the Kubernetes Data Protection Working Group meeting. This meeting will be recorded. We have two items to discuss today. Historically, we might have put too many items over there and we don't have enough time to go through all of them. So Shin and I discussed and think maybe it's time to reduce the load for a little bit and better amortize those detailed discussions into a smaller groups. First of all, we will go through some data protection workflows. Juan will focus on application backup and restore workflow, and that from his experiences. And then we have a couple of updates on CAPS, including snapshot, container notifier. I think Ben has done a lot of work in the generic data populator. And the Koji cap has been merged. And then we will leave the discussion to the group. Yeah, then let's get started. Shin, could you click on the first doc? I don't think we have any updates there, right?
Yeah, I think, yeah. So I just, let me open
Yeah,
the,
thank you. Fang, it's all yours. I'm handing over the mic to you.
Okay. So we did talk about backup and restore over. We want today we talk about mainly about the backup and restore workflow for application. So for the backup and restore, when we talk about backup and restore application, we don't only talk about the data that the application generate, but the entire ecosystem required for the application to run. With that in mind, we did look at various applications, and we found that there are mainly two general workflow. One of them is for the we call logical dump workflow, and the other one we can call it a snapshot, snapshot and backup snapshot workflow. So let's start with the backup first, right? Uh, when we back up the application in general, we want to back up first all of the resource that needed for that application to run first. Then we go to the data of that application. So the general workflow will be like this. First, we will back up, for example, the namespace, the cluster role, or anything that the application needed um, to even before the application starts. Like, so that need to be backed up first. That can be done by using like a Velero backup or something like similar tool to do that. But we're not talking about detail here. This is the first step. The second is the application. Before we go into the data, backing up the data, we might need to do additional step that put the application into specific conditions for backup. For example, in MongoDB, where we might want to disable the load balancer between the node before we go into backup the data. That can be done in the second step here. And then the third step is almost like the main step of the backup workflow, is where we back up the data. And during this step, there are two sub workflow. One of them is the logical dump. If you look into MySQL, you can see like MySQL dump do that. Other database application also have similar. I think in our meeting, somebody also raised the SCD, the SCD for Kubernetes SCD. We also use the SCD dump, which can be done in this step too. So, and then the second workflow related to this backup data is the snapshot. In the previous meeting, I mean, maybe two, three meetings ago, we have already talked about how to use these queries and unqueries using the container hook to do queries the application, then take a snapshot of the PVC and then unqueries and so on and so forth. So these are the steps that involve in the second in this second workflow for snapshot. I want to talk a little bit about this second the workflow here is that for some application, you might see that all ports are not equal, right? Some ports are primaries, the other one will be secondary. And the data among these ports, even though they are somewhat a replication of each other, but there is a relationship between them. For example, if we want to back up that 3 ports, then you have to back up the secondary first before you back up the primary, because the primary containing new data coming in. So during this snapshot and back up the data, we have to somehow serialize them into a specific order to being back up in the right order. But some other application, there's no need to be backing up these ports in this PVC in specific order, but they might have a different requirement. For example, you might want to back up these snapshots, have to be back up them very close to each other within a few seconds. And that where I think there's a design from Xingzhang's to snapshot the volume group, snapshot the entire volume, the group volume together. This kind of the consideration that we need to take into consideration during this snapshot action step. After the snapshot action, after the snapshot of the PVC being backed up, being snapshot, it will be backing up into the repository or the backend backup storage device later. So that is the third step. The fourth step is the opposite of the second step, as you see in the workflow, right? If we disable the load balancer, for example, in the MongoDB, if you disable the MongoDB load balancer, and then this fourth step, you have to revert back, you have to put it back to action. So you have to enable the load balancer at this point. So that is the general 4 step in the application workflow. It includes both logical dump or snapshot dump. The difference only at the third step, where we actually either take a logical dump or the PVC, the snapshot PVC way. So those are the different there. So that is the application workflow. Could you move to the next screen when we talk about restore? The restore also, we have to consider 2 workflow, one of them for logical dump and the other one for the snapshot. However, in the restore, there's 2 scenarios that kind of we have to consider them for separate. One of them is restore to entire new application. You don't even need to consider many aspects of the application that is currently run. The second scenario is we want to restore to the system that is the application that is currently running. We restore to production. So these two have to be we have a slightly different between those two, right? So let's talk about the first scenario where we want to restore using the PVC snapshot way, and then we restore to an entire new namespace. So the first step would be to using Velero or a similar tool to restore the entire namespace with the application in it. It might also restore the cluster-wide resource that's used by the application, right? as I mentioned above, the cluster role, all of that might, or the secret on a few things that being used by this application should also be restored in this step. The second step is restore the data. This is very important that you have to restore the data first before the restore the application. Because if you restore the pod, but you haven't restored the PVC, then the pod coming up, it will fail. So what we want to do is restore the PVC first, all the data first. Then when we restore the pod will automatically hook with this PVC. That is the third step. So let's talk about the second step, restore the PVC a little bit in more detail. The second step is that when we restore the PVC, first we will create an empty PVC, one or multiple one, depending on whatever you have in the backup. And then we will have to mount these empty PVC into some data mover pod. At that point, we can pull data from the storage, the backup storage, and put them into these PVC. Currently, we have two types of PVC, right? One of them is a raw block, which can be mounted as a raw block device on the data mover. The other one is the file system PVC, right? And then after we restore these data into the PVC, which is either the mounted directory on the data mover or actually the raw block on the device mover, then we will delete that data mover. When we delete the data mover, remember that the PVC is not being deleted. It's just the data mover pod being deleted. At that point, then the data mover pod can be removed. And then next step, we restore the pod, the stateful set, the service, etc. That at that point, the data is already available in the PVC. Then the pod will automatically hook up with these PVC and start running the application again. I want to talk a little bit about the data mover here. I think it's the general idea in the Kubernetes, but we have to use the data mover on demand because currently the Kubernetes have a restriction that we cannot mount a device on a pod during runtime. We have to mount it at when we specify the configuration to create the pod. So that is the reason when we have a new PVC, we have to create the new data mover pod there with that PVC mounted on it. And then after we're done with that, we have to delete the mover pod to unmount the PVC. And another thing I want to point out here is that most of these PVCs cannot be written at the same time by more than one pod. So that's why we have to delete the pod after we're done restoring data so that other pod can access to it. So that is the workflow for restore to new with the PVC snapshot. For restore to production, it's a little bit more complicated. Could you scroll up the screen a little bit more? It will be a little bit more complicated because the application, the namespace and the application is still running, the namespace is still there, and so on and so forth. And we still have the same restriction that I just mentioned earlier, that if an application pod is using that PVC, that data, right? We can not have another pod jumping in and mount that same PVC and start writing data to it. That is the current problem, right? Unless the PVC is, it have a different mode. It have read-write many mode. But most common application is having the read-write one mode, so it's only be able to write and read by one pod at a time. So if that is the case, then the first step we need to do to restore an application in production is we need to scale down the deployment of that application to 0. So if, like to say, if we have a deployment that have deployment config, the deployment that have 5 pods, and then we have to scale all of that down to 0. That means effectively we delete all the pods that currently is using these PVC. After we scale down to 0, all of the PVC now doesn't have anything mounting on it yet, then we will create a data mover with these PVC mounted on it. Then we will restore data to it. Now, because this data mover is the only part that access to this PVC, that we can write data to it, and we take the data from the backup device and write to it either as a block, raw block device, or a mounted directory, depend on the type of PVC. After that, we will delete this data mover, then scale back the application to the previous number of replica that it had before we scale it down. So these are the steps that need to be done for the read-write one mode. If you have read-write many, I think, I don't know if how many started vendor out there actually support read-write many, because that means that 2 pods can mount the same PVC at the same time and start writing both. I'm not sure how much problem you are buying into such a type. Okay, could you move down to the next page? So that was for the snapshot way of backup and restore. Now we're going to talk about restore to the using the logical dump. The logical dump is a little bit less complicated than the previous one, even though we still have to do some of the restore the namespace and so on and so forth. It's pretty similar to the previous way. But when we restore the data, then we just run the reverse of the logical dump operation. For example, you go, if you're using MySQL dump, and you just run MySQL dump again, but using the going the other direction. So that everything else should be normal. We can talk a little bit about, the logical dump, where the data of the logical dump will go and how will that go, how are that different from the PVC, and what is the good and bad. But I think we can talk about that in a different meeting, because this meeting, I believe, is only like introduce the workflow of it, right? So I think that's all I have.
So sorry to interrupt. I was on double mute earlier and I couldn't get off mute. When you're talking about read-write once PVCs, you can have multiple pods attached to read-write once PVC. They just have to be on the same node. That's I don't know what problem that is for the design, but it doesn't actually prevent multiple pods from attaching to a volume. It just means that they have to be on the same node.
That's the thing is that we have to yes, that can be the case, but what I concerned was that some of the PVC, they have a requirement of where they affiliate to a specific node. Then if we want to do that, we have to move, we have to create the pod, the data mover pod on that node itself, right?
No, it sounded like you wanted to use read-write once as a protection against a restore happening while a workload was still running. And I was going to say that you won't actually get that protection unless you can find a way to ensure that like you have different nodes for these things. And furthermore, like read-write many volumes are actually quite common, at least where I come from. We have NFS volumes and they're all read-write many. I don't know how many people depend on that functionality, but it's not zero.
Okay. I at least for my that's this. But yes, like I said, in this the flow here, that we consider both. If you have the read-write many, then or you don't have to concern about having 2 pods writing to the same PVC at the same time, because there might be some access violation there. So the application have to take care of that. If you don't have that concern, then you don't have to. You can skip some of the steps that I mentioned in. I also explicitly spell out what step to skip if you're using read-write many. I think in the first step in the restore to production, if you don't have a concern about writing multiple data more, don't have a concern that the data pod will write into your restore PVC at the same time with the application, then you don't need to scale down the application to 0, and you don't have to scale back in step number 3. I did spell it out there in the document. You can see it.
Okay, I'm still having a hard time wrapping my mind around the context for this whole discussion, because you're talking about some very specific management of approaches for doing restores, like with various applications, and my mind is more in the place of how do we develop something that works no matter what you're doing. I don't. It doesn't seem to me that a backup and restore application should, like, the layer that does the restoring should know anything about the application itself. Like you know, you need a facility to restore backup to a volume that is agnostic to what the application is. And then if there's any application specific requirements for like what you do after the data is back on the volume, then like that should be handled by a higher layer. So I don't know. I'm not entirely following like what the approach is here, because it sounds like you're actually like having something that understands the application and can like modify it so that the restore can succeed, and then put the application back into the state where it's supposed to be.
Right, but if you are actually backup and restore a stateful set, you do have to understand how that works actually. So I think maybe this is maybe we go a little bit too fast on this one. Yeah, so this one basically, I think he talked about like how you have to you know, you need to back up all the Kubernetes resources, right? Kubernetes metadata.
Well, this idea of basically restoring back to an existing PVC is the one that kind of makes me scratch my head, because like you can't do that with a snapshot.
Okay, so this part actually, so yeah, normally the like I would normally to this, you know, I'm more familiar with this one, restore to new. So the production case, yeah. So this one I'm actually, I need to read this again. So this is like you are not really creating anything new, so that you are like overwriting the existing one. Is that what this is, Feng? So you have PVC there. You are overwriting the data basically, right? Is that?
It depends on how you restore the data.
So let's just talk about let's not talk about the rewrite many yet. Just let's say.
I like the scheme where the restore happens to a new PVC, and then you attach your application to the other PVC, rather than trying to share access to some existing PVC, because that it seems like it opens up more than one cans of worms. Like it's like a case of cans of worms.
This is probably something people are already doing, right? So I'm trying to understand. I'm not sure how. Yeah, I haven't mentioned this.
No, there's nothing wrong with doing that, but like if our goal is to provide like a low-level facility that like lots of people can consume, like it needs to be very generic and compatible with all of the things, and it can't make assumptions about what's going on at the upper layers. We just need to be like, I'm restoring this backup, and like give me a volume, and once that's done, I'll take the volume and do whatever else I need to do at the higher layers, you know.
I have a question here, because I'm not, maybe we can actually focus on the new scenario first, but I just have a question for Fang here. So when you scale it down to 0, are those, so all the PV and PVC are still there? They're not deleted when you scale down, right? Is that? That's what it means. Yeah, right now actually there is upstream, there is some work trying to.
So this actually interrupt with the if like I said, if we have to scale it down because we concerned about having 2 pods accessing data at the same time, then we scale it down. But when you scale it down, you interrupt the workflow for the user, right? The pod disappear. The user cannot use the application during that time.
Right. So if you don't scale them down, so everything is still live, then
then two pods
Oh,
able to accept the data at the same time, writing to the PVC at the same time. You have to,
that would be a problem, right?
yeah. The customer, I think the application have to, if that is the case, then the application have to be able to handle that kind of.
So can you? Oh, you can't really. Yeah, how's it? I thought there was some place you're saying using a freeze. That's for. I thought somewhere has this. Where is that? I thought you have something saying we need to freeze it or use.
Yeah, we
bias.
can,
Where is
but
that?
that is for we. I think I mentioned that in the backup workflow, but in the restore
I
workflow.
thought in the restore, I thought you mentioned something about acquires. Well, I remember seeing something there. Did you actually have that somewhere in the restore workflow?
Maybe
thought-
not.
Oh, no,
I think maybe
that's
in
for
our
the-
discussion, but
No,
maybe not.
it's for the I think it's for the rewrite many. I remember you mentioned something. I remember maybe you removed that. I remember seeing something. They're saying, oh,
Oh,
maybe-
right there. And actually in the
Oh,
step
class.
of
Okay,
rewrite,
okay,
yeah.
this
If
part, right?
it is rewrite, yeah,
Rewrite
you can
many.
see that, yeah.
Okay, I see. Yeah. okay, so
I did spell out for both cases
Mhm.
where we allow multiple pods to write into it
Mhm.
at the same time, and also multiple pods can, I mean, or the case when you don't need. But I think I understand the point that if you want to provide a workflow that very low level that ignore what application run, that is very primitive, low level, and that works for some cases and might not work for some cases. I think what we are concerned here is the app consistent level of it, right? When
you need that higher level, but like you want to be able to layer the solution. So there's like something that takes backups and turns them into volumes. And then there's also something that takes applications and takes restored volumes and rebuilds your application out of it. Like you need both things, but like it feels like this is a very strange blurring of the lines that's going to put you in a position where like you're only going to be able to support some small subset of use cases because you're trying to solve both problems at the same time, and there's so many different ways that you can consume a PVC basically.
No, actually what I see this is that we don't try to solve the problem here. We just spelling out what needs to be done step by step, what needs to be done to restore and backup and restore an application on Kubernetes, right? We did talk about in the previous week, we did talk about what it needs to be done to backup and restore a pod, individual pod. And this one, we talk about how we back up an application that involves more than one pod, like multiple pod or multiple stateful set and service that are associated with it and so on and so on. So from my point of view, this one is like almost like a one layer up compared to the previous week when we focused on single pod and the PVC for that pod. Right?
Have you actually tested this approach that you listed here, like this resort to production? Have you actually, is this just something you think that might work? Have you actually tried
this? Actually is in production.
Oh, okay.
Yeah, but not all of it, not like the detail. Some of these, for example, the read write many, my product do not support that.
Oh, okay, yeah, okay.
Well,
maybe, yeah, go ahead.
Yeah, I got a couple questions over here. For restore to production, that sounds to me more or less like a rollback scenario. So why wouldn't user just choose to delete existing one and do a restore to new for clean solution?
This one actually allows you to do the CBT. So we only restore a few blocks, right? If you really want to go with the CBT, if you want to just say, I want to roll back to 2 days ago, and because if I restore the entire all of the data, right, it might take 3 hours. Instead of if I roll back this way, it's only I can using the differential snapshot, for example, then I can only need to roll back 3 blocks, for example. Then it would take a few minutes instead of 3 hours to restore all of the PVC.
Sure, but
don't
that's
you still
only
need to bounce the application in that case?
You see my point, right? My point is that you need to restore the PVC anyways, regardless is for a full backup or some CBT. But that should be handled by the PVC restoration, not from the orchestration point perspective. Is my understanding right?
I'm thinking.
Because we scale down the application deployment to 0 replica and bring it back. To me, it's more or less equivalent to just delete it and restore it.
Yeah, so the only difference here is we are not creating the whole volume again. We are just, like you said, right, rolling back the volume or roll forwarding, whatever. And
Sure,
Just
again, this
faster,
should be
probably,
pushed
right?
down
It's
to the,
faster this way, I think.
sure, but this should be pushed down to the volume restore perspective, right? Not from the application's angle.
Yeah, I mean,
So probably we need to talk more about this restore in production. We need to talk, I think, about more, but this is the general.
right. So restore to production, I guess we should maybe get restoring to existing PVCs and not creating new ones. That's the what we are addressing here, right?
You mean restore existing PVs, not PVC?
Yeah, PVs, yeah.
But the PVCs are also new, right? I'm also existing, right? You're not recreating any new PVCs either, do you?
No.
So
Everything's existing, yeah.
When we scale down, it deletes the part, not the PVC.
Yeah, okay.
I also it is also interesting that. Sorry, Ben.
I was going to say, well, go ahead. Go ahead.
I would also interesting to see whether we can better utilize the quires mechanism here, because the end of the day, you only want to freeze your application, whether you have if quires work is already doing this work, then maybe it is okay to just restore the volume and not touching the application at all, the Kubernetes resource at all.
Yeah, that's one of the steps I spelled out there, is that, you know, if you're able to, you can use queries to stop the application from writing into the PVC, then restore the data and then unqueries there.
I'm not sure writing is enough. I think read has to be blocked as well, no?
Probably, because the read can read the wrong data when we are restoring, right? Even with the wrong combination of data. Yeah, that's a good point. I think that's a good point. Maybe queries both read and write, I guess. Like
anyway,
like a data block.
Sorry, Ben, you have some question? We can discuss this more.
Well, yeah, I was just going to say, like, can you guys hear me?
Yes.
Yeah.
If we were to build this on top of, like, if you have a snapshot mechanism, I'm going to take a snapshot of my application using Kubernetes snapshots, and then I want to restore those snapshots. Like, the way that works today is you're going to get new PVCs, right? Because that's how snapshot restore works. And it doesn't seem like such a big deal to me to tear down all your pods and rebuild them pointed at the new PVCs. Like, I don't see how trying to restore back to the original PVCs is a big win. Like,
there might be a performance issue, maybe from Sakana, you guys can chime in.
Well, no, I mean, you need I'm presuming that you have the fastest possible way of reconstituting a PVC from a backup, and that's efficient, and we don't explain how. But like, if it is, and you end up with a new PVC, the rest of it seems to make sense to tear down the old stuff and rebuild a copy of it pointed at the new PVCs.
I think you got the point there that if I restore the entire PVC all the time anyway, then the difference between restoring to existing one and restore to a new one and swap it in doesn't make a lot of difference. However,
but that's the only thing you can do with the snapshot. That's what I'm getting at. Is like, until we have a way to do.
No, actually, we are proposing the CBT, right?
Right. So that, Ben, that's one case, right? But there is also a case where the snapshot's not there. It's in an on-prem world. Usually the snapshots are deleted and the data is moved to a secondary storage. So in that
they're
case,
not really. Yeah, I think that Ben, I think they're not really using create volume from snapshot because snapshot is local, right? So the data is already uploaded somewhere else in a backup device. So you have to kind of download
No,
that data.
all I'm getting at is like, once you have backup objects that you can create and then restore from, like you would like to be able to use the same mechanism with your snapshots as you can with your backups. And that you would like to have some symmetry there.
It is, I think backup time uses, I think that would use snapshot. It's just, I think the restore time, this is not using the create volume from snapshot because.
That's what I'm getting at is like, if there was a way to just like say, hey, I took this snapshot from this volume and now I'd like to roll this volume back to the snapshot that I took, like that would be exactly like what you're describing here. Like I want to roll the volume back to the backup that I took. And so like, if we had the same functionality and it was just like, oh yeah, roll back my application, like that would kind of make sense to me. But like, I don't know why we would implement something for backup that you can't even do with a snapshot, because then like snapshots become a lot less interesting, right? Then it's like, well,
I mean, yeah, I mean, unless if your snapshot is actually like a remote one, right? Like AWS EBS, right? That's automatically upload somewhere, or some driver can also do that, where they upload a snapshot somewhere. Then in that case,
but then they're really taking a, I mean,
mm-hmm.
Then semantically what they've done is they've created a backup and they've called it a snapshot. And the moment you create a facility for actually taking backups, they'll be like, oh yeah, that's just a backup. And they, so.
I'm not getting what you're trying to say. Are you saying it should always just create volume from a local snapshot, or what? I'm not getting what.
I'm saying like the thing that you do at the Kubernetes API layer to effect the restore, like when you create, or the API object that you use, right? Like right now, the way that you effect a restore of a snapshot is you create a new PVC, you give it a data source, you point it at the snapshot, and boom, your volume pops in. Like I'm envisioning that like there will be something similar for backups, and like whether it is efficient or not is an implementation detail.
Right. So yeah, if we have that, I guess this is basically.
But like I'd like to understand like what is the low-level Kubernetes API operation you would undertake to say, okay, here's my backup. I don't want a new volume. I want the backup to just go back to this volume from whence it came, and like and somehow magic will happen, and maybe change block tracking is using, or and the data will get there. Whatever we do there, we should also do for snapshots to maintain the symmetry. That's all I'm getting at. Is like,
I think that's a good idea. I mean, it basically from abstract level, snapshot or data from the data backup device. Basically, it's just a bunch of blocks and then of the data at a specific time in time. If you can think of it that way, then, but whether it can map nicely into a symmetric way in Kubernetes, that is the question, right? In Kubernetes, if you have a snapshot object already there, then you can create a PVT pointing to that snapshot as a source. But if the data is in the backup data storage, it's not even have any snapshot object presenting it, then you cannot do that directly. You have to somehow create a volume on the storage device and somehow transfer the data from the backup storage all the way to that storage device that being used by that PV. So that is a little bit more complicated.
I wonder, should we actually look at your Ben, your proposal on the external data populator? Because that would be a good one, right? So then you can just create a PVC from some other data source. That could be your backup repository.
The whole thing there is yeah, like we have a way to turn snapshots into volumes, and we imagine that someday there will be backup objects you'd like to be able to turn into volumes, and we'd like to be able to implement that without changing core Kubernetes, so that so that we can do it quickly. That's the whole point behind the data populator's work, is when we want to create a new thing that you can turn into a volume, we want to be able to implement that without having to change the core API.
I think,
but this other thing of like, I'd like to basically overwrite an existing volume. Like I find that very interesting, but like I want to understand what the user does at the Kubernetes layer to make that happen. Because you don't create a new PVC, and it's not obvious like what you would send a Kube API server that would say, hey, I have this PVC and I have this backup, and please, make it go back in time, or if it would be done some other way. Like that's the thing I'm not wrapping my head around.
I have this question too. I mean, when we create a new PVC to use, does that require? I mean, does it generate a new name, a new UUID, and all that stuff?
Yeah, will be new. There will be new UUID. Yes.
Would that be affecting how the pod using it? And
well,
if you're creating new pod, then you can use it, right? You're not going to be existing pod.
So
you could delete the old PVC and create a new one with the same name.
Should we actually look at this one at first? So are we okay with this, like restore to new? So this is the one, if everything's new, then it should be this workflow, right? The restore to new case. Are we all?
Yeah, actually we're on 45 minutes mark, Xin. I know there's still there are still a couple of other items in the agenda. We can postpone them if everybody.
Yeah, that's okay. Actually, I think because those are, we can actually go very quick. So do we want to take a look of this and then? So Ben, is this workflow? Does this match what you have in mind?
Sorry, I'm not in front of a monitor.
Restoring, okay.
Let me run back to my monitor. I mean, yeah, all the workflows that I had in mind involved creating new PVCs, and I'm just trying to figure out, like, is there really a disadvantage in doing that? Because like Sean was saying, scaling a stateful set down to 0 is the same thing as deleting it from a functional perspective.
I think you don't. Well, this is just when you bring it back, you basically you scale it up, right? So I think that, I'm not sure what's the difference actually.
Yeah,
scaling down and deleting.
Yeah. I got a couple questions, but in general, it looks fine to me. But I got a couple questions. I think we need to resolve those questions ahead of time. First of all, is the sequence. The namespace and cluster-wide resource expect PV restoration might need to happen after PVC has been restored, because there's a strong dependency over there. Because imagine you have a stateful set. If you restore the stateful set the first, and then go ahead and you restore the PVCs, and these PVCs might be used by the pods created by the stateful sets already.
I think those should be later. Yeah, do you have those here? Okay, maybe Feng should add those. Yeah, those resources should be restored later after the data.
If you scroll up, Those go up on the restore to new, right? You can see.
Okay, yeah. Okay, so he has this one here. Yeah.
Yeah,
okay.
At the bottom. Yeah.
Yeah.
So because the PVC is actually namespace, is in a namespace scope. So if you want to restore the PVC, you have to restore the namespace first.
Yeah.
Sure, but
so yeah, it's actually here. So
I saw it, but the thing is that namespace and cluster-wide resources is a very blurred term, right? There are many namespaces like kube system, kube public. Those are default. Those are not restorable. Those are not deletable, right? Cluster-wide resource, the same thing. You probably don't want to restore a volume snapshot, for example, right? So I'm not sure whether we should be explicitly calling this out in the beginning. And that's the only thing I was thinking.
So probably more detail there, right? You have
Can we actually just use one like you put like a YAML for stateful set there and then use
Yeah.
that as
So
one
I think
example. That's
formed,
for more concrete.
What we should say is create the namespace, not restore the namespace. So if it's not present, you just create that namespace and then.
So far, I think that may be helpful if you just take like one simple stateful set example and just put the YAML file there and see, what are the resources that we're restoring at this time, at this step, and what is the, things that we are restoring at the end. Maybe that will be helpful because this is very general when you say, classify resources, that's too many things included. Yeah, that'll be better than the scope will be smaller, right?
My concept is only restore the cluster-wide resource that actually needed by the application, right? Whatever is used by the application only.
Okay, yeah.
Not just any cluster-wide resource.
Right. I think that a concrete example will help here, I think. Yeah.
And another thing is the data mover part. That is basically effectively very similar to Ben's data populator. So I want to hear his opinion as well on this. But one thing I was thinking originally is that create empty PVCs, right? And this PVCs doesn't necessarily need to be the PVCs the application will be using in the future, right? It can be temporary PVCs and then transfer the volume, the underlying PV after the population has done. I think that's how Ben did it. Is that right, Ben?
Yes. Well, go ahead, Shane.
Is there do we have two PVC here actually as well? Or I see there's a target PVC, and then you create a empty PVC. So do you also have like two PVCs here?
That's the same. That's the same.
Okay.
Yeah. Okay.
So the thing I wanted to emphasize about the data populators is like I'm not trying to prescribe like the mechanics of how data should get from wherever it is into the volume. The whole point of the data populators work is to create a framework where you can create CRDs that represent something that has data that can become the data source of a new PVC, and have Kubernetes basically treat that like the existing cases of data source snapshot or data source PVC that implement a clone of a snapshot or a clone of a PVC. You can basically do a clone of a something else. And I'm fairly agnostic about like what actually happens after that. Now I do have a specific prototype of like a way to do it that does involve like creating a second PVC, and then after the PV has data in it, like swapping it in for the PVC that the user actually requested. And I'm happy to go over that again. And in fact, we now have weekly meetings on Tuesdays where we're talking about data populator related stuff, and people are welcome to come to that because we will eventually get into the mechanics of how we actually populate things. But that this is all of that assumes like your goal is to create a new PVC. So I'm not saying it's a bad idea to like overwrite existing PVCs, but like I really want to understand the user interface for that. When if I have something and I want to and I want to tell Kubernetes like put that something in this existing PVC, like how do you do that at the Kubernetes API layer and such that a controller could see that request and do the right thing at a very low level? Because once you have that, I understand like you can build all the upper layers and build a really fancy application, aware backup and restore system, but like just the low level nuts and bolts of like, here's my data, here's my PVC, make the data go into the PVC, like that's kind of a hard thing to do, especially with the way the Kubernetes API is kind of declarative. It's like, where would you declare your intention to make that happen? It's not obvious.
Yeah, that would need a new API. That we can't use one API.
But that's what I'm getting at. I feel like I feel like there's something missing.
Can we, Phong, can you like talk about what's the like advantage of the second, like, why do you need to do the second approach? Why the first one does not work for production? I think it's like that part is missing here.
why we need to restore to the existing namespace with the existing application is running on it.
Yeah, maybe if you can give some reasons like why, what's the advantage of doing this way than creating everything new. Yeah.
What is the namespace? So if you want to restore the, let's just say you have to create a new namespace, right? Some of the namespace would have to, some of the element in the namespace can be used. If you look into like a Helm chart or something, they embedded the namespace name into their address that being used by the pod that is running.
No, so I guess Fong's question is why not tear down the contents of the existing namespace and restore it back? So I think maybe since here we're just addressing the workflow. So what I guess Fong's trying to convey here is, say you have an application, it has a multiple file system volumes, and say one file got corrupt. So now you want to restore that file. So it's not necessarily tied into Kubernetes API, but a workflow could be you go into that backup application, select the file you want to restore from the copy that was created onto secondary storage, and you select restore, and then the backup application will scale down the pods. The application is not running. It will connect to that PVC, the existing PVC, restore that file, and then scale back up the pod. So it's nothing to do with Kubernetes API. It's just
okay.
So that's like a partial restore case, right? So that's
You're talking about a workflow that a tool that understands all this stuff could undertake on top of Kubernetes.
Right.
And I guess my mind is that, how do we provide a Kubernetes API that just lets anybody do this stuff? And it's two entirely different questions. And that's why it's not making any sense to me. Okay.
I agree with Ben. I think that's too application oriented. Maybe it's gonna be very, at least to me, it's very challenging to achieve that via some generic mechanism.
I kind of lean toward that too. I mean, maybe the restore to production may be too specific for the generic workflow, but we can use the restore to new, right? Completely restore to new. I think that's okay. But restore to production maybe for a specific application for a specific vendor to implement.
Yeah, I always
we want to create an interface that like consumers can consume and providers can provide, where there's like multiple implementations on both sides that work together, because that has value as a standard, right? And that was sort of the point of the data protection working group, was we're trying to develop a standard that we're like consumers of backup APIs and producers of backup APIs can all implement the same thing, and then we can have an ecosystem that actually works, rather than having like one tool that just does all the work, in a very specific way.
That's correct, Ben. That's exactly
one of the restore production that we can. One example that we do is the CVT. Right? If we have a CVT implementing in the Kubernetes layer, then restore to production might have a lot of values there for efficiency restore, right?
Yeah. So like that's an argument for like we should define a change block tracking API and then get everyone to implement it. And then once we do that, people who want to consume it to build things like that are free to do so. But like, I think the working group's responsibility would end at like, here's the API, it works. Build what you want on top of it, right? Like I thought that we also wanted to go down the path of like, not only, are we going to have a change block tracking API, which I think there's pros and cons to doing that, but we're also going to have a formalized backup object that means something that the Kubernetes API understands, and you can say, hey, turn this backup into a volume for me, and like whatever your CSI driver is, or whatever your distro of Kubernetes you have, like the right thing happens and out pops a volume that has your data. Like that's also really useful.
Yeah, we do have a work stream for that one, right? So yeah, right now we don't have a concrete design, but it's just some initial thoughts.
For the sake of this, workflow, I think we only spell out the steps. We haven't talked about implementing yet.
Yeah, this is like just some general steps. So yeah, maybe we can focus on this restore to new for now. Ben, do you want to go over the data populator again, maybe in the next meeting? I think that will be helpful to refresh everyone's memory.
Well, I could, but like we have a time slot now, and I would just encourage people to come to the volume populators
Right. But are you going
meeting.
to actually go doing like overview again in that meeting? I thought that one is more kind of specific on things that you
Well,
want to talk about.
yeah.
Or
I am happy to use that meeting or this meeting and to go over it again. It's
okay.
what people want to hear.
Okay,
Like,
so we can talk about
motivated
that later. Yeah. Mhm.
I am motivated to like get work done in that Tuesday
sure.
afternoon meeting.
So we can forward that meeting to this mailing list as well. So if people are interested, they can join that one. Yeah. I think we are running out of time. Yeah.
I think we should do this, right? So
Mhm.
for smaller groups, if you are looking, please share the meeting details in this document, in the working group document, so that anyone who is interested might choose to join, right? And that's probably a better way of organizing all this.
Yeah, I have a Google Doc for the agenda and all the links, and we can just link to that here.
That'd be great.
You can put that in the general the agenda doc. Yeah.
Yep.
Okay.
All right. We are on the 10 o'clock mark. Thank you, Paul. It has been really helpful. And thank you, everyone. I'm stopping break. And enjoy the rest of the day.
Thank you. Bye.
Okay, thank you. Bye.
Bye.